Hi everyone, and welcome to our video on graphing a shifted cosine function. So first thing we want to do, let's scroll. I'm going to scroll for a second. We want to make sure it's in the correct form where, notice in this, so I underlined it, I'm going to bold it again. The x minus or plus whatever is in its own parentheses, and the coefficient on the x is 1. So that means we need to take out anything that has a coefficient besides 1 on the x. So on this first one, the x has a coefficient of 1. The 1/3 was taken out already. This one was set up for us real nice. This one, so if you are following the printout of, if you got the printout, I changed it a little bit. So make those adjustments right now. So just a couple numbers change, but if you don't have the printout, doesn't matter. All right, so follow along right here. Okay, so what we're going to do is put it in the form. First thing that we want in the form, and this is a preference thing, but I think it's nice. I'm going to put the trig function first. So I'm just rearranging. So -6 cosine 2 pi fifths x minus 4 pi fifths, and then plus 4. Okay, so there was a positive on that 4, just moving it. And now I need to factor this part. Okay, and when we factor, all we do is we're going to factor out the coefficient on x. Okay, so 2 pi fifths is the coefficient. So we're going to take that out of there. So 2 pi fifths, and then do a bracket like their form, and then parenthesis x, and then minus, and then parenthesis bracket, and then plus 4. Okay, so I'm just leaving some space there. Now, when you factor, remember you can double check by distributing. So I'm just showing some dots that will be used to check in a second. So the 2 pi fifths times x is that. Okay, so it matches right above, or this one. And then what I can do, I mean, I can guess and check to try to figure this out. So you might see it that way, but another way to do this, when we're factoring two terms, and it doesn't matter if these are common or not, but when we factor, it's a lot like division. So to find this missing term right here, we divide the second term, so the 4 pi fifths, the second term, by the x coefficient. Okay, so that work would be then 4 pi fifths divided by 2 pi fifths. And then just some scratch work. Okay, so 4 pi fifths times 5 over 2 pi. The 5's cancel. The pi's cancel. 4 divided by 2 is 2. So this should be just minus 2. Okay, and then when you double check with distributing, notice 2 pi fifths times 2 is the 4 pi over 5. So it is a match. Okay, so now we have it in the correct form. So I'm going to cloud this up. This is the correct form. And now we proceed like the previous problem. So we'll get our a value, which is -6. And when it's negative, I would say make a highlight. We know we're going to reflect. However, though, they're going to want the amplitude, which is always the positive value. Okay, so we got the amplitude. This is our b value. So our b is 2 pi over 5, which means the period is always 2 pi over whatever that b value is, 2 pi over 5. And then my strategy is to just multiply both top and bottom of the big fraction by the small denominator there, so that way I can get some canceling. And then simplify, so this becomes 10 pi over 2 pi. And then we could reduce that. I'm going to put that over here. 10 divided by 2 is 5. The pi's cancel. And then I'm going to get these just in blue. Okay, so the x minus 2, that's part of the phase shift. I'm just going to put both arrows down. our phase shift, so with the x, think opposite, the phase shift is +2. And then the vertical shift is that +4, is just 4. Okay, so the 2, that's to the right. The 4 is meaning we're going to go up. Okay, so we've got that information too now. I'm going to box that. But from here, we're going to use our amplitude and period and just make a quick sketch. Let's do that down below. And cosine, I'm doing this dotted, is usually something like this. But remember, it's a reflected cosine, so just getting my dots ready first. So it would be something more like that. Okay, so we reflect it. So there's our reflected cosine curve with 6 as the peak and -6 at the bottom. Let's mark our 0 origin. And then now we'll use our period, which is 5. So we mark that on the x-axis, and then we'll do our halving technique. Okay, so let's half it. That's to multiply the denominator by 2. So this would be 5/2. And then multiply it by 2 again down there, which would be 5/4. And then multiply by 3, the numerator, 15/4. Okay, so there's our 5 important x coordinates there. Now we'll use our shifting. So I'm going to mark our phase shift. I'm going to keep that, actually, oops, I'm going to move that a little up. So now we're just doing arithmetic. So we have our sketch is going to look like that, but we need to just kind of move things around. Okay, so our phase shift is to take the 5 important x coordinates, so 0. Actually, let me color code still. So 0, 5/4, 5/2, 15/4, and then 5, and use the phase shift, which is the horizontal shift. That's our addition of 2 to all of these. And so now we'll do that arithmetic. Most of them need a common denominator, but this first one's nice, 2. And then now we'll get our common denominator. I need a 4 down there, which means that needs to multiply 4. So we have 8 plus 5 is 13/4. And then 5/2 plus 2. Okay, so I need to multiply both top and bottom by 2, and that gives us 9/2. 15/4 plus 2. Let's change that. Okay, so we need really 8 plus 15 is 23/4. And then 5 plus 2, that one's nice, 7. Okay, so those are our new important x values. So those are in order connected to these 5 important x values. Okay, so to highlight now, we'll come back to those highlights. Okay, and then now I'm going to do the vertical shift in purple just to the side. I usually just do it on the y-axis. So vertical shift is to go up 4. So that means we should add 4 to all of those y coordinates there. And that we don't really need arithmetic, I would say. We can now start to plot it. So here's just our normal xy axis. And then I do the vertical shift first on the actual graph. So going up 6, we're going to say, well, there's 10. Going up 4, or going up 6, I meant 6 up 4, 6 plus 4, that was that part. That's 10. 0 plus 4 is 4. I'm going to say that's about there. And then 4 minus 6, well, that'd be -2. So maybe about there. So it's not perfect to scale, but good enough. And then the other thing that we want to do is draw in a new axis. And it might be better. So I did dotted before. I'm just going to do a solid purple. Oop, got a little curvy. Okay, so this is the new x-axis. So that's our focus. Okay, and then now we're going to plot all of those blue ones, all of the phase shift now, those guys, on this new x-axis. Okay, so I'm going to say here's about 2. And then we'll just try to go equidistance. Okay, so again, it doesn't have to really be to scale. So 13 quarters, I'm going to say is about there. And then 9 halves. And then 23 quarters. And 7. Okay, so those are those new x coordinates. And now we'll match the pattern that we had from the original non-shifted graph. Okay, so we said, it's already kind of highlighted. I'm going to highlight more. This 0 is now where 2 is on the x. And then comparing the points, it was down below. So that should be the down below one. And then where 5/4 was on the original is where it crossed the x-axis. So that means the 13/4 is where it should cross the new purple axis. Where 5/2 was on the original graph is where 9/2 now is, and that's at the higher peak. Where 15/4 was on the original is where 23/4 is now, and that's back at the new x-axis. And then where 5 was on the original is where 7 is now, and that's down below. Okay, so those are the highlighted spots where I need to put my points. And then now I can do my best to draw a cosine curve. Okay, so through those, I'm going to kind of leave it blank there so I don't cross the number. Okay, so there we are. Okay, so that is our sketch. That's it, finally. Okay, and with this, it's pretty clean. We've said before, we can always label points. Like, for instance, this is the point 9/2 and 10. And we could do it with all the others. However, I want to label that. I'm going to double check one last time here. So I'm going to check to make sure that that x coordinate gives me this y coordinate back in the original function. So all the way back there. So in case I accidentally messed up somehow. All right, so we're gonna plug in 9/2 into x, and that gives 4 minus 6 cosine parentheses 2 pi fifths times 9/2. So that's where the x went. And then minus 4 pi fifths. So we want to see what this does. And then we get 4 minus 6 cosine. Okay, so over here, notice the 2's would cancel. Goodbye, goodbye. Then we would have 9 pi over 5 minus 4 pi over 5. Well, 9 minus 4 is 5. So it'd be 5 pi over 5. Well, the 5's cancel. So cosine of pi is -1. So this would be, so I'm squeezing out of room. That's why I'm skipping some of those steps too. But cosine of pi is -1. And then we would see, oh, 4 minus 6 times -1, the two negatives would become a positive. 4 plus 6 is 10. Okay, so it matches. So it does work, at least for that point. So you might want to try the others. That should work just fine. Okay, so you can always check it. Okay, so one last thing about this too. So I like to factor these style problems out when it's not in the form that it should be in. Okay, so back up to here. So I like these forms better. I think factoring is more important in other things in math. Okay, so but there's other ways to do these style problems. So sometimes students don't like to factor this and they work with it a different way. That's fine. Okay, so but I'm not going to do that. Okay, because this is my last one anyway. Okay, so factoring I think is stronger for lots of other things in math. That's why I prefer this method. Okay, so and also one more reminder, these letters A, B, C, D, they can change the letters. Okay, so that's not a big deal. Okay, but anyway, that's it. Okay, so if you do have questions, please let me know. Otherwise, thanks for watching, and I'll see you again next time.